Hi, and welcome back to Algebra 1. Our goal for today is to start to look at the process of factoring binomials or factoring polynomial expressions. So we're going to start as simple as possible with what are called linear binomials and how I go about factoring. There are two things I need to understand how to that will help me with the idea of factoring, which is, do I really understand the process of expanding, and do I understand the process of how to calculate a GCF, or greatest common factor? So our focus for today are those essential skills that are going to help us ultimately with that process of factoring our polynomial expressions, and more specifically what are called linear binomials. So to start, when we have something that looks like this, that 4 times 5k plus 7, you guys are used to seeing this. It is what's called the factored version. It's what I've been giving you. And then I've been asking you to take that expression and simplify it or expand it. And so the process of simplifying or expanding is when we take the outside item and we multiply it with the stuff on the inside. And the result, that 20k plus 28, expanded. That 20k plus 28 version is the result of doing the process of expanding. If I understand that, then the factoring is the undoing of that process, or going from this version back up to here. So for today, our goal is simply just reviewing, can I expand my expressions, which is really a fancy way of saying do the distributive property, and can I calculate the greatest common factor of my term? So of this term 20k and this term 28, can I find the GCF of those particular terms? So starting with our review of expanding. All right, we want to expand the expression 2 times 5x minus 8, which is just saying take this 2 times that's on the outside and share it to these items on the inside. When we do that, we'll get a 10x, and then 2 times negative 8, which would give us a minus 16. From there, no like terms, so I can't keep going. 10x minus 16 then is our expanded version, or what the problem looks like without the parentheses is the expanded version. I want to expand the expression 3y minus 1 times 9, which just means take this 9 times that's on the outside and share it to our items on the inside to get the expanded version, or what the problem looks like without parentheses. So 9 times 3y would give us a 27y. 9 times negative 1 would give us a minus 9. And no like terms there, so we are now in our final simplified expanded version, or the way the problem looks without parentheses is our expanded version. All right, reviewing our greatest common factors. So remember, GCF is the greatest number that goes into our original number. So if I said, what's the greatest common factor of 24 and 63? We're looking for that number that is the highest one that goes into both of those original numbers. In this case, 12. And sometimes making a list like this works, or making a mental list like this helps us get that GCF. But we also looked at how to make a tree and chart, right? Use our prime factorization tree in our chart to help us get that greatest common factor. So review for today, how do I create a prime factorization tree and a chart to help me get that greatest common factor? And in this case, since we're going to be using it to help us with that task of factoring, we always want to start with our terms here of 1 in our number, or negative 1 in our number. And I'll explain why as we go through examples. So we want to take this term of 4x and find its prime factorization, and this term of positive 30 and find its prime factorization. So these are both positive. So we're going to start with 1 and 4 and 1 and 30. And I know 1's not prime or composite, but it's going to be helpful to us when one or both of our numbers are negatives. All right, so we want to start there with either a 1 times or a negative 1 times. So if this was a negative 4x, this would be 4 and negative 1. All right, from here, 2 and 2 and a x. And then over here, 6 and 5 is a way to go, and then 2 and 3. Now, here's where people are still messing up with their charts. Each column has to be identical. They have to match. You can't put for example, my first number here is a 1. I can't put like a 2 or a 3 or a 5 down below it. They have to match. That's the point of making the chart. I'm lining up common digits in my prime factorization statement. So there's a 1 here and there's a 1 down here. That column's done. So now I'm going here, looking for the next lowest number, which is a 2. There are 2 of them for 4x, a 2 and 2. Done, done. For our 30, there's just 1. So I'm putting it here. And then this block is staying blank. Yeah, quit putting different numbers in there. They have to match. That's an empty block. And now we go here for our next number, which is a 3, and it goes on the bottom, which means this guy's staying blank because there isn't a 3 there. Don't put a letter or something goofy there. All right, these have to match one another, so be careful. All right, our next number is a 5. It only goes on the bottom. Again, there's nothing up here. It stays blank. And then finally on top, there's an X. It doesn't go here. It goes here in the next open column because there was no X for the bottom. All right, GCF says I look for every column that is completely full. If I put a 5 or something else here, right, or a 2 there, or put the 3 there, then I think those columns are full, and they're not. Those are empty. So our only columns that are full is this column with a 1 and this column with a 2. So our greatest common factor would be a 1 times a 2, or in this case, a 2. So be careful. All right, let's try another. Number 2. What is our greatest common factor of the given terms in the expression negative 10x minus 75? All right, so we'll find our GCF of the terms in that binomial. All right, these are both negatives. So instead of 1, we're going to start with negative 1 times 10, right? That would get us back up here to 10. The same thing here, negative 1 and 75. You will only break down a positive version of the number, positive version. Pull the negative out first. All right, now that we have positive 10 and positive 75, then we can go to its prime factorization. All right, so 2 and 5 here would give us our 10. And we have this x. And then over here, I know 75 could be 25 and 3. Right, there's different combinations. And we can also use a 5 and a 5 here. And we could have divided up here by 5 or 3 also. All right, let's start to break it down. Our first number for both of these is a negative 1. Done. Our next lowest number is a 2, but it only goes on the top. This top is this negative 10x. This bottom one has to stay blank. Don't put something random in there. All right, our next lowest number is a 3, but it only goes on the bottom, which means this top block stays blank. Quit putting stuff in there. All right, from there, we have a 5 on top, a 5 on the bottom for this one and this one. But then there's another 5 for the bottom, which means the top one's staying blank. All right, from there, we have an X, but it's just on the top. All right, GCF says now that we have our things lined up, any column that is completely full, we multiply to get our GCF. So this column is full, and this column is full. We multiply those, and we'll end up with our greatest common factor of negative 5. All right, let's look at one that is a trinomial to start. We can do the same thing with our terms. This one is a negative, so we need to pull out the negative 1 and get to positive 60 before we start breaking it down. This one's a negative, so again, we need to pull out our negative 1 and get to positive 25 before we start breaking it down. And this one's positive, so it's just 1 and 5. And 5 is prime, so we're done back there. All right, 60. I don't know, 6 and 10. 2 and 3. And a 2 and 5. And then m squared, so 2 n's. All right, 25 would give us a 5 and a 5. And m to the first would just give us an m. All right, we're ready to start making our chart. Our lowest number here is a negative 1, but it only is part of these first two. So negative 1, negative 1. This bottom one here is going to stay blank. Do not put your positive 1 in there. It does not match. Our next number is a positive 1, which goes in this next column over. So be careful. I can only match up things that are identical in the same column. All right, from there, our next lowest number is a 2. So for this 60, there are 2 of them. So 2, 2. All right, there's none in this middle row for 25, and there's none on the bottom for 5. So we're now on this. These all have to stay blank because they didn't have 2s. All right, our next number is a 3, which is right here for the first number of negative 60. Again, these bottom two don't have 3s. All right, then we go to a 5. There's 1 up here, 2 in the middle for negative 25m, and 1 down here. Bink, bink, bink. All right, now all these other blocks stay empty. We're now right here for our M's. There are 2 of them. 1 of them, none of them. And now that we have things all lined up, we're looking for columns that are completely full. Things that are completely full, we can multiply to get our GCFs. In this case, there's only 1 column that's completely full. If I put this 1 over here, I'm going to act like -1 or maybe +1 is part of the GCF, and it's not. So be careful. So our GCF here is just simply a 5. All right, I hope that helps you attack your work for today. See you guys later.